Hi guys, and welcome back. We are continuing with our discussion on exponent sets and equations that involve exponents as well at grade 11 level, of course. And I'm just going to go through a few problems that I had asked you to try out in the previous video. And this, of course, your first tutorial on this. And I hope this will just iron out some issues and it will help you to check whether you are correct or not in the remaining problems. So out of the 5, I'll do only 3. So let's look at this first one here. 45 to the exponent of minus n plus 1 times 5 to the exponent of n minus 1 times 81 to the exponent of a negative 1, very important, all over 4 to the exponent of n plus 2 times 36 to the exponent of minus n minus 1. What you want to start with here is to actually express these bases 45, 81, 36, and 4 in terms of prime numbers. Now, a prime number is a number that has only 2 factors, namely 1 and that number itself. For example, 2 we know is the smallest prime number that we have because it only takes 1 and itself. Okay, in other words, 2 divided by 1 is 0. 2 divided by 1 is 2 and 2 divided by 2 is 1, okay? Now, I'm going to teach you how to use your calculator to factorize. Let's start with 45 here to prime factorize, actually. So you're going to type in 45, followed by the equal to sign or button. And then what you're going to do, you're going to press Shift. Then there is a button or there is a writing in yellow called fact. This is in yellow. Maybe I should use a yellow ink here. So that's what you're gonna press after Shift. You're gonna press fact. The button actually has the signs. It's like the degree sign and those minutes and seconds sign. So it has got these. This is the actual button, but at the top is written fact. So once you press that, you must get 3 squared times 5. So this tells you that 45 is actually 3 squared times 5. So, and you notice that 3 is actually a prime number, 5 is a prime number. So it has done the job for you. You don't really have to struggle with a lot of things and all that. So I'm going to go ahead and do the same for all the other numbers. So we now know that, okay, 45 is 3 squared times 5. So this is all, right, to raised to the exponent of negative n plus 1. Remember, we are multiplying. 5 is already prime, so we don't really have to do much. You do the same thing with 81. And this is obviously 3 to the exponent of 4. And then, but notice, don't forget, this is all to the exponent of negative 1 all over 4. Come on, guys. This one, you don't need a calculator. 4 is 2 squared. And then this is exponent of n plus 2. And then what is 36? Quite interesting if you do this one. If you prime factorize this one, you're going to get 2 squared times 3 squared. Okay, my writing may not be visible, but I hope you can hear what I'm saying and be able to make sense out of that. And all this is raised to the exponent of negative n minus 1. Okay, let me just clean up a little bit here. Now, that being said, guys, the next thing that happens is to now apply our law of exponents. Remember, the law says a to the exponent n, all to the exponent m is good as saying a to the exponent of n times m. That's what we are going to do. Now, what happens often the case, most of the times rather, is that learners get to be caught up, especially when now an exponent is composed of 2 terms, like the negative n plus 1 here. And the examiner, of course, is deliberate, very deliberate about this. Often folks will multiply the n out and leave out the positive 1, which is why I will always stress that it will be nice to put some brackets there. It will be really nice to put out some brackets, especially where there are 2 bases with inside the bracket and there is an exponent involved. It is helpful to do that. So you'll see then I'm going to have 3 to the exponent of negative 2n plus 2 times 5 to the exponent of negative n plus 1 times 5 to the exponent of n minus 1 times 3 to the exponent of a negative 4, just multiplying out the exponents, 2 to the exponent of 2n plus a 4, not a 2, be careful, times 2 to the exponent of negative n minus 1. In fact, I fell for the trap, so I must fix this. It should be 2 to the exponent of negative 2n minus 2. So if you caught me there, well done, you are awake. To the exponent of 3 to the, times 3 to the exponent of negative 2n minus 2. Now, I'm just going to continue here. I can tidy up by grouping actually the 5s together, the 2s together, the 3 together, the 3s together. In other words, the same basis. I'm going to put the same basis together here. So let's start with 2 as the smallest base. So this is, of course, there are different ways to clean up here. At this point, you can decide to clean the numerator first, then the denominator. That's still good with me. I don't really have a problem. In fact, I think it will be best to do that so that none of you will be confused. So let me do that. What you're going to notice now, guys, is that if you look at the bases that have got a 2, they are only in the numerator. Now notice that you're going to add the exponents because bases are the same. So 2n plus a negative 2n are actually going to handle each other there, and you're going to have 4 minus 2, which is a 2. So you're actually left with a 2 squared there. I hope you see that. So you are actually left with a 2 squared in the denominator. Now, let's see what happens with the 3's. There's a 3 to the exponent of negative 2n and a positive 2. There's a positive n there and a negative 1. Sorry, that's for 5, so we don't have we discard that. We must come here to the negative 4. So let's sort out the numerator, the 3's quickly. So here's a 3, here's a 3, and there's a 3. So you notice that actually this negative 2n will actually cancel with the 1 at the bottom here. Because the signs are the same, when you take one to the numerator or denominator, it will cancel the other. Now, you've got to be very careful with the 2's. What you should notice is that this negative 2 here, if I take it up, it becomes a plus 2. And there's already a plus 2 there, which becomes a 4. And then a 4 minus a 4 is actually a 0. Somehow then, if you heard what I said, the 3's, if you take everything to the numerator, will simplify to exponent 0. You'll have 3 to the exponent 0. So think about this. Take 2n up. Also take the negative 2 up. So they will change signs. So they will become something like, let me just write it here as a courtesy. You'll have something like, if you take these things up, you're going to have plus 2n plus 2. Okay, so you can see this 2n handles that. Now, here, these two things are going to give you a negative 2, but if you combine with this, you get a 0, because negative 2 plus 2 is 0. So that's why I'm left with that. So I hope now everyone is on board. So finally, let's look at the 5's. Let me just pick a different color. If you look at the 5's, I've got a 5 to the exponent of negative n plus 1 and a 5 to the exponent of n minus 1. But you'll see that negative n plus an n is 0. 1 minus 1 is also 0. So actually, I also have here 5 to the exponent 0. Now, I have accounted for all bases and exponents. Therefore, we know anything to the exponent 0 is 1. And then 2 squared is a 4. The final answer is a quarter. In other words, 1 over 4. Notice I'll say to you, this step is not necessary. Really, it's just cleaning up so that you see what you have. But the critical step is the one here where I've put many colors, and this one, the final answer, of course, and that one, of course, also, even the second step here. So I think for me, in a classwork setup, I'll give 1, 2, 3, 4, 5, 7 marks for this problem, but in a test question, I'll definitely give it 5 marks. So I hope you got something from this. Sorry for taking long. Cheers, guys. Catch you later.